Before you look at this screencast, you should look at the previous screencast and try to solve these examples yourself. Now, the first example is to rank these substances, hexane, 2-hexanol, and 2,5-hexanediol, according to their volatility, boiling point, and so on. So let's start with volatility. We look at the compounds and see that, well, hexane is a non-polar substance. 2-hexanol has a polar group here, a hydroxyl group or an alcohol group, and 2,5-hexanediol has two alcohol groups, two polar groups. The length or the size of the molecules, it's essentially the same. What you don't see here is that there is a hydrogen atom there, or actually two. Here there is a hydrogen atom and then an hydroxyl group. So only difference between these two is that we have added an oxygen, just one atom, and here we added another atom. But the important thing is that we have one polar group in this substance and two polar groups here. And the more polar groups we add, the stronger the intermolecular forces are. So the volatility should be smallest for this one and highest for this one, because hexane is a non-polar and 2,5-hexanediol is a rather polar substance. And with the boiling point, it should be the opposite. So the lowest volatility is the highest boiling point, and the highest volatility is the lowest boiling point. What about water solubility? Well, like dissolves like, and water is a polar substance, and this is a more polar substance than this one, and this 2-hexanol is more polar than hexane. So 2,5-hexanediol is the most polar of these three substances, so the water solubility should be largest for 2,5-hexanediol and lowest for hexane. And the fat solubility, or if we should be more accurate in our naming of things, the solubility in organic solvents is the opposite of the rank for water solubility. So 2,5-hexanediol has the lowest fat solubility of these three, and hexane the highest. So what about excretion rate? Well, that follows the water solubility. So the excretion rate is lowest for hexane and highest for hexanediol. Finally, what about bioaccumulation and biomagnification? Well, the problem is that we do know things now about the fat solubility, and for something to stay in our body, it should be fat soluble or somehow get stuck, like lead gets stuck in our body by getting incorporated in our skeleton. But if you eat fat, it might not bioaccumulate because the body might be able to break it down. But we have no good rules of thumb for how easy it is to break down these substances. And as a matter of fact, I've chosen these because it happens that 2-hexanol is a metabolite of hexane. When you ingest or inhale hexane, the body responds by turning this substance into 2-hexanol, and in the next step it turns it into 2,5-hexanediol, and then 2 further steps. So these are actually related in the body. So, and it just proves how difficult it is to say anything about biomagnification and bioaccumulation. Okay, so this is our ranking, but what about the reality? Is this ranking any good? Let's see. The boiling point, if you look that up, it's approximately 69 degrees Celsius for hexane, 140 for 2-hexanol, and 217 for 2,5-hexanediol. So it's a perfect match with our ranking. And the water solubility also matches perfectly. But what if we take this a step further? When we discussed these rules of thumb, we didn't care where these polar groups sit. And there are 3 different kinds of hexanols. It can sit on the first, second, or the third carbon. The 4, 5, 6 is just a mirror image. I mean, you can start counting from here, 1, 2, 3, right? So you have 3 different kinds of hexanols with one alcohol group, And you have a number of different alcohols with 2 groups. Let's just look at 3 different versions: 1,6, 2,5 and 2,3 hexane diol. And if we look up the physical characteristics, we see that these 3, 1-hexanol, 2-hexanol and 3-hexanol, has approximately the same boiling point, from 135 up to 160. And the water solubility ranges from 5.9 up to 16. If you go to the diols, the ones with 2 alcohols, the boiling point ranges from 205 to 249. So for all these 3, the boiling point is larger than the boiling points for the ones with 1 alcohol group, and that in turn is larger than the boiling point for hexane. If we look at the water solubility, we see that the 2,5 hexane diol is a rather extreme one compared to the 2 other ones we see here, 23, 530. So we see that 1,6 hexane diol has 23 grams per liter of water solubility, while 3-hexanol has 16. But it's still actually 1,6 hexane diol is more water soluble than 3-hexanol. So our simple ranking still makes a pretty good job. Okay, let's take the second example. Here we had 1-hexanol, 1-heptanol and 1-octanol. And if we take volatility, well, the difference between these 3 is that 1-octanol is a longer or a larger molecule than 1-heptanol and 1-hexanol. And this is a bit like having Velcro. If you have a short Velcro, it sticks not so good, and if you have a long Velcro, it sticks better. So the forces between 2 molecules of 1-octanol is larger than the intermolecular forces between 2 molecules of 1-hexanol. So the volatility is lowest for 1-octanol and highest for 1-hexanol. And the boiling point is just the opposite, so the boiling point should be lowest for 1-hexanol and highest for 1-octanol. What about water solubility? Well, the carbon chain here is a non-polar thing, so the fraction that is polar is highest in 1-hexanol, and 1-hexanol is also a smaller molecule, so it makes sense that the water solubility should be highest for 1-hexanol and lowest for 1-octanol, and the fat solubility should be just the opposite ranking. And the excretion rate is likely to be highest for 1-hexanol, since that is more water soluble, and lowest for 1-octanol, since that is less water soluble. So let's check that with reality as well. And we see that the boiling point matches perfectly, and the water solubility also matches. So what we've seen here is that with pretty simple rules of thumb, we can make pretty intelligent guesses of which substance is more volatile and which is less volatile, which substance is more water soluble and which is less water soluble.